Okay, I'm going to show you how to do some of the force problems on a slope. All right, first you're going to be drawing a skier as a box on a slope. We're going to have three force vectors that we're going to be worrying about. We're going to have force of gravity, which causes the box to slide down the slope. We also have the normal force, which pushes up on the box, which is normally there. Force normal. And then we have the force of friction, which works backwards. It keeps it from either sliding down, keeps it from accelerating, or not going as fast. Force of friction. So those are three forces that are acting on the box. All right, let's just, here's my box. Three forces acting on my box. So we're still going to use the idea of some of the forces. We're going to try just the x direction first. So here is my x-axis. And how do we write some of the forces? So we write force net, or add up all the forces that are acting on the object, and we're going to set it equal to ma. Now, if you read the problem, sometimes it tells you if it's going to be accelerating. So how fast is a skier going 5 seconds after starting from rest? So let's find what the A is. It's probably accelerating. Let's see if we can figure this out. Well, how many forces are acting on the object? Well, we're going to call force down due to gravity. I'll put down. This is this right here, this vector right here. All right, the force down due to gravity plus a negative force of friction. And we're going to set that equal to ma. Now, force down is only a component part of mg. So this, we want the x component part. So if we break this up into two parts, it's going to have this part, one vector, and this part, another vector. We only care about this vector. I'm going to pick a different color. I'm going to try to do black as a color. This is a component of this piece. I'm not going to really get into this, but this is going to be mg sine theta. Just in case you need to, sine theta is opposite over the hypotenuse. Here's your hypotenuse, and here's your opposite vector. Trying to draw it thicker. Okay, now going down, here's your FD. So I took this black vector and I'm just kind of made it go parallel. Alright, so this is my force down vector due to gravity. I'll make this all black right here. Force down due to gravity. Now I can start substituting in what I know and what I don't know. Force down is actually mg, mass times gravity, or fg, either one. I'm going to take the sine component of my gravity mass cause. Alright, I'm going to do plus, I'll do green I guess, plus a negative force of friction. Now what is force of friction? Force of friction is mu Fn. Where did I get that from? That is a formula that you look up in the back of your physics reference table. Set it equal to ma. Whoa, what the heck is force normal? Oh, force normal is this blue vector right here. Well, where do I get force normal? Well, force normal usually is a gravity component, but this time it's only half of it. It's this portion of it. So this is reflected up. So this is mg cosine theta. So force normal is mg component part cosine theta. Now let's go back to rewriting our problem. Mg sine theta plus a negative. We'll keep mu. And what's my force normal? My force normal is like right here. Force normal. Mg cosine theta. Set it equal to ma. My mass of 65 kilograms, my skier, slide it down. All right. Now, I don't know if you can see this, but there is an M in everything. There's an M here, and there's an M here. And if I really wanted to make my life simple, I could cancel the m out. It's in all the parts. If you have a little problem with that stuff, just keep mass in there. It's given to you. Alright, now, what is it asking for? I'm trying to find out what A is. I know what G is, that's gravity. I know my angle is 37 degrees. Oh, by the way, this 37 is the same angle right here. I don't know if you can see this. I'll try to 37 and that. Those two angles are the same. Alright, so I'm going to put in values. 9.8 meters per second squared times sine of 37 degrees minus 0.15, that's the coefficient of friction, times 9.8 meters per second squared cosine 37 is equal to A. Oh, it's got a weird number. Let's see. Eventually I'm going to get 5.89 minus 1.17. My units are meters per second squared is equal to A. Eventually, A should be 4.7 meters per second squared. Alright, I gotta erase this because I need more room. We have not solved the problem because we are looking for what happens 5 seconds after it starts from accelerating. So I am erasing the board. Apparently I can't. Okay, continuing with this information, I have now found that A was equal to 4.7, it's approximately 4.7 meters per second squared. Now I have to find out how fast that's going to be a velocity, final, after 5 seconds. There's your time starting from rest. My V initial is equal to 0. So I plug in what I know, what I don't know with an equation. So V final equals V initial plus AT. Easy smeezy. This one's 0 because of the word rest. V final is what we're looking for. Trying to find that one. We know A because we just found A, and we know time. Time is 5 seconds. 5 seconds way over here. Alright, plugging in all the numbers that we have V final is equal to 4.7 meters per second squared times 5 seconds. It's the last part of the problem. Probably like, oh, I can't do that. Oh, yeah, you guys, you're smarter than you realize. 23.5 meters per second. Oh, how did I get rid of the seconds? Went there and there. My final unit, mass and seconds. Meters per second. Oh, I said mass, I meant meters. Okay.